I gave you my heart.
Hey guys, so welcome back sa ating YouTube channel. So ito na yung ating lesson 41 para sa ating probability theory. So this is lesson 4.6, expected value of sums of a random variable ng chapter 4 Latin, which is the random variable. So now we start with this. So I guess nasabi ko na itong property na to nung una pa lang, ng property na isang expectation, na ang expectation of x is just, kung naalala nyo, expectation of x is just the summation of s element for s element of s, x of s, then p of s. So ang ibig sabihin lang ng x of s na yan, it's something na ganito siya. This is just equal sa summation, okay, or something na tawag dito, s element of s. So for example, this is x sub 1, so x sub 1 plus x sub 2 plus x sub 3 plus plus x sub n. Then ito ay p of s. Okay, so ang representation ng x of s natin, yung x of s natin is yung mga sum ng mga random variable. So where, lagay ko lang dito, where yung x of s natin is just equal sa x of 1 or x of 1 plus x of 2 plus plus x sub n. Okay, so yan yung atin. So yan nga, sinasabi niya, yan yung sum of random variable. So ang sabi nga dito, the expected value of the sum of random variable. So now, bibigay ako dito na example na kung saan hindi natin na-applyan ng kahit anong alam natin na probability mass function. Kasi aware ka na ano yung Bernoulli, ano yung binomial, ano yung geometric, ano yung Poisson, ano yung hypergeometric, ano yung negative binomial. So meron din tayong zeta. Okay, so what if hindi natin ginamit yung way na yun? So for example dito, suppose that two independent flips of a coin that comes up head with probability p are made. Okay, so again, suppose that two independent flips of a coin that comes up head with probability p are made. So again, iibahin ko siya in a sense na magkakaiba sila ng random variable. So we all know na since head yung pinag-uusapan natin, una, ang mga random variable o yung mga values ng random variable natin, let's say x, una is for 0, pangalawa for x is equal to 1, and lastly for x is equal to 2. Okay, so this is the case or event na kung saan walang head. So two independent coin, walang head na lumabas, or pwede ko siyang i-name as ganito. So again guys, pwede mo siya i-name as ganito, x of t comma t. Okay, this is or x of h comma t. So since dalawa siya, mutually exclusive yan, x of t comma h. And lastly, or x of h comma h. Okay, so yun yung representation nilang dalawa. So kung napansin mo, sila ay mga random variable. So ito yung tinutukoy ko niyan. Okay, so ginawa ko silang in terms of random variable. So hindi lang values yung ginawa ko. Okay, so now ang goal natin is hanapin yung expected value. So now hindi natin alam kasi totally kung ano yung mga magiging probability. So kung ang probability na lumabas yung head is syempre p, kasi p yung sinabi, with probability p. Okay, so ang probability na lumabas yung tail, syempre yung sinabi ko, kung p yan, ito ay 1 minus p. Okay, so tandaan, yan yung mangyari. So ngayon, ibig sabihin, ang probability ng pair, so let's say t comma t, ang probability ng pair, since independent sila, again, independent sila, okay, again, independent tong flip na to, independent yung flip na to, so meaning, ang probability ng t comma t is just, for example, this is probability of t times probability of t, which is equal sa 1 minus p raised sa 2. So ganyan yung gagawin natin dito. So yun yung function ng pagiging independent flip. So again, di tayo gumamit ng kahit anong probability mass function, kung bagkus gumawa tayo dito. Kung baga alam ko independent sila, so therefore itong comma to yung p of t comma t is just equal sa p of t times p of t. Okay, so now try na natin compute yung expected value, kasi expected value talaga totally yung pinapahanap dito. Okay, so for the expected value, so for the expected value of x, okay, so this is just equal Okay, so for the sum, so this is just equal sa una, for x of 0, so this is x of t comma t. Okay, multiplied by the probability ng t comma t. Okay, then plus x of h comma t plus x of t comma h. Okay, so ito medyo magkaiba pa sila, no? So mo-multiply pa natin to, no? So ito mo-multiply pa natin sa probability ng h comma t. So hindi nalagay ni sir, multiplied by probability ng t comma h. Okay, then lastly plus x of h comma h times the probability of h comma h. Okay, so again minumultiply ko sila lahat. So note that x of t comma t is 0 times probability of t times probability of t plus h of comma t. Okay, so h of comma t, this is just equal sa yung value nito. This is just equal sa 1 times 1. So something na x of h comma t, this is 1. Kasi 1 lang talaga sa totally. So this is 1 times probability ng h and t times probability of h times probability of t kasi independent plus 1 times probability of t naman times the probability of h. Then plus this is 2 multiplied by probability ng h times probability of h. So now substitute lang natin. So obviously this is the 0, or kunyari this is 0 times this is 1 minus p raised sa 2 kasi dalawang p of t yan. Okay, then this is plus. So wala na yung 1, so this is just p yung p of h times 1 minus p para sa t. Then plus, wala na yung 1 na yan, so this is just 1 minus p times p. Then plus, this is just 2p times p, this is p squared. Okay, then let's simplify. So obviously ito ay simplify natin, no? So ito ay magiging 0 na lang plus p minus p squared plus p minus p squared ulit plus 2p squared. So obviously negative p squared minus negative p squared is negative 2p squared plus 2p squared is cancelled. So therefore this is just equal sa 2p. Okay, so ganyan yung magiging approach mo if ever gusto mo siyang i-distribute as independent random variable. So kumbaga ginawa ko ng sariling random variable si x with sariling probability. Ginawa ko ng sariling random variable si x is equal to 1, which is may sariling probability kasi dalawa yan. Then x is equal to 2 na meron din sariling probability. So kumbaga na-represent ko sila as independent random variable. Okay, so pwede mong gawin yung ganyang approach. So kung hindi ka makapag-decide anong klase ng probability mass function yung gagamitin mo, ito yung gamitin mo. Okay, so now for random variable, so let's have corollary 6.2, no? So for random variable x of 1, x of 2 up to x of n. Okay na, for random variable x of 1, x of 2 up to x of n, so independent sila again. So ito yung another pwede natin gawin. Let's have corollary. So the expected value of the summation of x of 1, x of I for I is equal to 1 up to n. Okay, so yan yung kumbaga yung expected value ng mga random variable is just equal sa summation nung expected value nilang lahat. So ang ibig sabihin lang, yung expected value, so sulat ko lang dito ng x of 1 plus x of 2 plus dot up to x of n. Okay, is just equal sa summation. Okay, or simply burahin ko yan. It's just equal sa x of 1, expected value ng x of 1 plus expected value ng x of 2. Then plus dot plus expected value ng x of n. Okay, so sabi nga nila the expected value of the sum is equal to the sum of their expected value. Okay, so yun yung ibig sabihin dyan. Okay, so now ang goal natin is syempre i-prove natin yan. So para at least makita natin na kaya ba siya. Tapos using yung 6.6. So ito yung proof. Okay, so let natin na z. So consider natin tong part na to. Let natin na z is equal sa summation for I is equal to 1 up to n ng x sub I. Okay, so by proposition 6.1, since na-represent ko na sila as iisang sum, kumbaga yung sum ng mga random variable natin na-represent natin as z, so meaning pwede ko na siyang gawin as x of s. Okay, so yun, x of s na siya. So ito yung mga sum, so ang ginawa ko siya ay x of s na. So by proposition 6.1, this is just equal sa summation, okay, summation for s, element of s, ng c of s tapos p of s. Okay, so yan ginawa ko. Next is, note na yung z of s is yung x sub 1 up to x sub n. So pwede kong i-rewrite yung mga part na yun. So this is just equal sa, tanggalin ko na yung diba, since c of s is yung summation na yan, so lalagay ko siya totally dun. So this is just equal sa summation s element of s, so this is just x sub 1. Okay, so x sub 1 of s, or x sub 1 na lang, or sige lagay ko s, x sub 1 of s plus x sub 2 of s plus dot plus x sub n of s. Okay, then p of s. Okay, next is syempre distribute ko yan dyan. Okay, so di-distribute ko siya kasama yung di-distribute ko yung p of s, tapos kasama yung summation, kumbaga pag-iwalay ko na. So this is just equal sa summation s element of s ng x sub 1 of s p of s. Okay, plus summation ulit s element of s x sub 2 of s p of s, then plus dot plus, so lagay ko lang yung huli, this is just summation s element of s x sub n of s p of s. Okay, so note na ito yung x sub 1 of s p of s is just yung expected value ng x sub 1. Tama? So ito yung expected value ng x sub 1. So this is just the expected value of x sub 1 plus expected value ng x sub 2 plus dot plus x sub x expected value ng x sub n. Then kunin natin summation. So this is just summation for I is equal to 1 up to n na expected value ng x sub I. Okay, so therefore this is done. Okay, so therefore na-prove ko siya na ganoon siya. Okay, then lastly, syempre, let's have an example. Find the expected value of the sum obtained when n pair dice are rolled. So yun, n pair dice. So hindi natin alam kung kailan matatapos yung n pair dice na yan. So kailangan natin siyang i-solve. So using yung ating corollary 6.2 and corollary 6.1. So ano ba pwede natin gawin? So since hindi natin alam expected value of sum obtained when n pair of dice, so hindi alam natin, so pwede na, since alam natin sum yung hinahanap pero hindi natin alam ang specific sum yung kailangan, so find the expected value of the sum lang obtained when n pair dice are rolled. Kumbaga hindi natin alam kung ilan yung dice wala totally, no? So kunyari 20 siya, so ano yung mga sum, possible sum dun, so yun yung kailangan natin makuha dito. So expected value, sa bagay expected value lang hinahanap. So mag-let lang muna ako. So let x be the sum, and we need to compute. So we need to compute for the expected value of x. Okay, so ito yung required natin na kailangan computed. So yan yung, so question mark. So ano ba pwedeng gawin natin? So since hindi natin alam kung ano yung mga possible na lalabas sa die, tama? So may mga possible value tayo sa die actually. 'Di ba? Yung mga number lang die, yung upturn side ng die is yung 1, 2, 3, 4, 5, 6. Kung pag ni-roll mo, mga possible na lalabas na outcome lang is 1 to 6. Okay, so maglelet lang ako muna. So pwede kong i-represent na yung x, yung random variable x natin is yung summation nung 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, pero since hindi natin alam, pwede natin represent as ganito. This is just a summation for x, x is equal to summation ng for I is equal to 1 ng x sub I up to n, kasi hindi natin talaga totally alam ko ilan sila kasi n pair dice yung itotos natin. Okay, so again, ito yung ating mga tawag dito. Sorry. Hindi ko kailangan isulat to. Sorry. Ang kailangan ko lang isulat is something na ito. So yung x natin, yung beta sum, siya yung summation ng mga x sub I for I is equal to 1 up to n. Kasi hindi natin alam po ilang n per days yung isa iaano natin. Okay, so another thing, since alam natin na yung 1 over yung 1, 2, 3, 4, 5, 6 ay may pare-parehas na probability. Okay, so we all know that the probability nito, okay, so let's say P of I. So we all know that the probability ng kada P of I from 1, 2, 3 up to 6 is just equal sa 1 over 6. Okay, so suppose likely na sila ay independent. Kumbaga, independent by trial. Okay, so now, kailangan natin computein yung expected value nito para makuha expected value. Again, pag kinumpute ko yung expected value ng summation nitong x of I, para makuha ko yung expected value ng e of x. Okay, so meaning, ang gagawin ko lang, kukompute ko expected value ni e of x. So, pag gusto kong computein expected value ni x, kailangan kong computein expected value ng summation ng I is equal to 1 up to n ng x sub I. Okay, so yan yung kailangan nating computein totally. Okay, so next, by corollary 6.2, so kung napansin mo ito na yan, ito na gagamitin natin. So by corollary 6.2, by corollary 6.2, this is just equal sa summation for I is equal to 1 up to n ng x sub I. Okay, x sub I. Expected value ng x sub I. So, lagay ko dito yung expected value ng x sub I. Okay, and which turns out na kailangan natin kunin ang summation ng x sub I. Okay, so note na for example, pumili ako dyan. So, ang expected value ng isang x sub I is just equal sa summation for I is equal to 1 up to 6 ng I tapos P of I. Okay, where P of I is 1 over 6. So meaning lahat ng yan, so para makuha natin expected value niyan, this is just equal sa syempre yung sum, no? 1 plus 2 plus 3 plus 4 plus 5 plus 6 times 1 over 6. Para yan dyan. Okay, so again, sa E of x sub I, yun sa kada isang E of x sub I. So, therefore, this is just equal to 1 plus 2 plus 3, that is 6 plus 4, 10, plus ito, that is 21. So, this is simply 21 over 6, or simply 7 over 2. Okay, so 7 over 2 yung mga summation na yan. So, meaning, para makuha natin to, para makuha natin yung summation neto, so, aware tayo na this is just equal sa summation for I is equal to 1 up to n ng 7 over 2. Okay, and note na meron tayong property ng summation. So, di ko na nalagay. So, kunyari, meron tayong property ng summation for I is equal to 1 up to n. For example, this is x. Okay, this is just equal sa property ng summation. This is just equal sa x times n. Okay, so kunyari, hindi ko siya kumbaga walang epekto siya. Kumbaga parang anong nangyari, wala siyang epekto doon. Kumbaga yung I wala mapapalitan. Ang gagawin ko, i-multiply ko na lang yung upper boundary. So this is n times x. So dito ang gagawin ko, since wala akong mapapalitan ng I, 7 over 2 times n. So therefore, this is just equal sa 7 over 2 n. So therefore, ito yung kanyang expected value. Kasi nga, n pair dies. So kung whenever n is 7, so 7 over 2 times 7, that is 49 over 2. So yun yung expected value ng sum. Pag 7 yung dice, 7 pair dice yung na-roll natin. Okay? So that's all for this video. So hoping nga na-gets mo kahit papano si sum na expected value. So kung again, kailan mo siya gagamitin? Gagamitin mo kung hindi ka makapag-decide anong klaseng discrete random variable siya. Kumbaga, hindi mo maklasify kung hypergeometric or geometric, binomial, negative binomial, Poisson, zip. Okay, so hindi mo siya ma-classify as ganun. Therefore, ganito mo na lang gawin. So, kumbaga, independently, check mo yung mga random variable. Kung mayroon ba sila kanya-kanyang probability, then i-add mo na lang. Okay, so gamitin mo si proposition 6.1 and syempre si proposition 6.2. So, that's all in this video. Hoping na may natutunan ka.